we are going to discuss another problem of maze strategies. Suppose the game problem is this. Player A has four strategies, strategy 1, 2, 3, 4. And player B also has four strategies. The outcome for every combination of strategies are noted on the matrix, and this is called payoff matrix. You have to solve this game problem. How you will proceed? Always first try with the help of minimax and maximum criteria or tools. In this problem, I am not going to repeat it detailedly because we have already solved minimax maximum criteria problem previously. However, just I am discussing it with. For first row, the minimum element is 5. For second row, the minimum element is 0. For third row, the minimum element is 0. For fourth row, the minimum element is 10. 10 is because out of 55, 60, 10 and 15, 10 is the lowest one. Now, for maximum, you have to select the maximum value from the selected minimum elements. That means out of 5, 0, 0, 10, which is the maximum one that you have to select. In this case, it is 10. That's why maximum value of this problem is 10. Now, minimax. Column wise, the maximum value is noted. For first column, the maximum value is 55. For second column, the maximum value is 65 because out of 65, 20, 50, 60, the maximum value is 65. For third column, the maximum value is 25. And for fourth column, the maximum value is 15. And you have to select the minimum out of all these maximum values, means 55, 65, 25 and 50. And the minimum value, that is minimax, is 50. The minimax is 50. And you see the maximum and minimax is not same. That's why you can write minimax not is equal to maximum. That means there is no saddle point exists in this problem. That is no equilibrium point, no solution of these 2% zero something. They are here and they are here. Then what we have to do next? We have to go for dominance property. I have already discussed in a previous episode or previous video how the dominance is applied for reduction of the game problem. Again, I am discussing in brief. First, reduction. How? See, second row is dominated by row 1 or here. You see, second row for all the elements, 35 is more than 30, 65 is more than 20, 25 is more than 50, and more than 0. That means all the elements of row 1 is more than row 2, respective element of row 2. That means you can say for player A, row 2 is dominated by row 1. That means player A will never select the row 2, and for that the row 2 can be deleted. And this is the first reduction. And the revised matrix will be this after first reduction. That is, the row 2 is deleted and the remaining elements is written in this. Okay. Now again search for any dominance. Again you can check that. Again you can check that 55 is more than 35, and this is 65. There is no any dominance. If I compare with this, then 55 is more than 40, 60 is more than 50, 0 is 10 is more than 0. That means row 3 is dominated. That means row 3 is dominated by row 4. Or row 4. Row 3 is dominated by row 4. And that's why we can delete the row 3. Okay? And the reduced matrix will be 35, 65, 25 and 5 like this. This is the reduced matrix. Okay. Now again see that now again you can check column 2 is dominated by column 1. Column 1 because 65 is more than 35 and 60 is more than 60. That's why you can say player B will never apply the column 2 for strategy 2 because the value is higher, which is in favor of A, and the reduced matrix will be 35, 55 and after deleting 25, 10, 5, 15. In the similar process, the reduced matrix will be 25, 10 because column 1 is dominated by column 3. That's why you can delete column 1 or strategy 1. And this is the reduced matrix, and it is not possible to reduce further, It is the maximum reduction. Then what you will do after this, when you reach to the maximum reduction on the matrix, to solve the game problem, again you try minimax maximum theory. That's why we have done minimax maximum theory. In this case, the minimum value is 5 and the minimum value is 10. The maximum value of the minimum is the maximum value of the minimum. The maximum value of the maximum value is 10. The maximum value of the minimum value is 10 and this is 1, 10, and the minimum from the maximum value is 15. Again, there is no minimax is equal to maximin. That's why you have to apply for mixed strategies. And mixed strategies, we have already shown in my previous video that how we'll apply the mixed strategies, and the formula we have developed there. That means in this case you have to apply the strategies in probability form. The strategies will be like this. The probability P for player A will be the strategies P will be this. The value will be this, and I have already noted above the values. P will be 25, B this. If you put and solve, then you will get the probability of first strategy for player A will be 1/5. And if you know the probability of first strategy, then the second strategy, that means in this case the reduced value is this of second strategy will be 1 minus 1/5. That's why it will be 4/5, and the value of Q will be this by applying the formula of probability. At Q 1 minus Q will be this, and the value of the game will be 3. This indicates that the player A will apply first strategy with the probability 1/5. That means out of 5 times first strategy will be applied once, and the second strategy will be applied, the probability will be 4/5, and the player A will never apply strategy 3 and 4. And for player B, the best strategies will be player B will apply third strategy with the probability 2/5 and the fourth strategy with the probability 3/5. And that means player B will never apply strategy 2 and strategy 1, and the value of the game will be 30. That means the game is in favor of player A, and the magnitude or value is 30.